The story of vaccines starts more than 1,000 years ago in China. The son of a prominent official had died during a smallpox outbreak. A monk who practiced medicine wondered, could he stop smallpox from spreading to others? He had one clue. Those who survived smallpox tended not to get it again. So the monk tested a theory. He scratched bits of smallpox sores from infected patients, ground them into a powder, and had healthy people inhale it. It helped. Historians believe it raised immunity by as much as 30%. Only 1 in 100 died. The technique, called variolation, was used for centuries. By the 1700s, it was widely used in Europe and America. In the modern era, scientists learned why variolation worked. It was preparing our bodies to be ready for attack by germs. Doctors agree, your best defense against disease isn't a shot or a pill. It's your own incredible immune system. Every second, your army of disease fighter cells is battling endless attacks by germs. They can even find and stop some tumors from growing. So here's where vaccines come in. They work by training the immune system to identify invaders before they enter our bodies. Traditional vaccines, like the one you may take to prevent the flu, polio, or measles, use a weakened or dead virus. When that injected virus gets into the body, it's like a big green light to your immune system to spring into action. It goes into work producing B cells, which pump out antibodies, and T cells, which are unique to that specific germ. It's the immune response that gives the sensations we recognize as being sick, not the germ itself. Later, your immune system is prepared to respond to attack. When it detects the virus, it pumps out fresh defenders called memory B and memory T cells, and the immune response starts again, hopefully defeating that infection. So that's the power of vaccines. But why did scientists adopt the mRNA approach during the pandemic? Well, before COVID-19, researchers had actually been working on mRNA vaccines and therapies for decades. mRNA was originally discovered in 1961, and the first lab test on mice was for a flu vaccine in the 1990s. mRNA is a long molecule that serves as an instruction code, telling our cells to make specific proteins. Scientists can write those instructions as part of new super-targeted vaccines. For COVID-19, there's 2 mRNA vaccines in use, shots from Pfizer and Moderna. Each instructs cells to produce a harmless part of the virus's exterior, its spike protein. Once injected, your cells make lots of copies of that spike protein. You won't get COVID because it's just making the spikes, not the virus. Your immune system recognizes the copied spikes as foreign and makes antibodies to destroy it. It even gets rid of the RNA itself. All that's left are memory B and T cells that can quickly spot another SARS-CoV-2 virus in the future. So when COVID-19 later enters your tissues, your immune system recognizes its spike protein and attacks. Against the Omicron variant, research suggests that 2 Pfizer shots and a booster are 65% effective at preventing any COVID symptoms. Moderna's shot and boosters, 70% effective at preventing symptoms. mRNA vaccines have unique advantages over traditional shots. Scientists say mRNA is easier to get into the cells in the body in large doses. Factories don't need live viruses to make it, and it's easier to manufacture large amounts quickly. Perhaps most importantly, it can be tweaked to respond to new dangers like emerging variants of the virus. It's that flexibility that makes mRNA treatments so exciting. Researchers are developing mRNA vaccines for malaria, HIV, influenza, and many other diseases. Dozens of clinical trials are now underway to test mRNA therapies for cancers, including melanoma, pancreatic cancer, and colorectal cancer. When targeting infectious diseases like COVID, the strategy is to mass produce mRNA vaccines targeting one key protein for everyone, but for cancers, it's an individualized approach that takes months per patient, at least for now. The promise of mRNA is that it's a pinpoint approach that attacks only cancer cells. By contrast, traditional cancer therapies like chemotherapy kill cells throughout the body. With mRNA's proven success fighting COVID, scientists are more optimistic than ever at its potential. And how it could help patients long after the pandemic is over. Lindsay Thies, Newsy.